This video is about thermistors and LDRs, which are two special types of resistors. So, our basic circuit diagram for a fixed resistor is just simply a rectangle like this. Now, this might be a fixed resistor with a fixed value, let's just say of 50 ohms, for example. Now, the next type of resistor that we could have, that we will have encountered, is a resistor that has an arrow going from the bottom left through to the top right, which is our variable resistor. So this just means that we have the ability with a variable resistor to change the resistance as we wish. So this maybe could go from 10 ohms up to 100 ohms, for example. And we could tweak that by moving the slider. The other name for a variable resistor that you should be aware of is a rheostat. Okay. So we use variable resistors all the time, but sometimes we don't want to be able to, or don't want to have to change it manually. We want a device that will respond to certain stimuli. So this is where our thermistor comes in. So a thermistor looks like a regular resistor, but with like a hockey stick across it. So this is our thermistor. And what a thermistor does is it behaves in the exact opposite way to a regular resistor. So let me explain what I mean by that. If I was to increase the temperature on a wire, or I was to increase the temperature of a normal fixed resistor, what happens is the resistance is directly proportional, which means as I increase the temperature, the resistance will also increase, like so. So that would be the shape of the graph. So that shows resistance is directly proportional to temperature. One goes up, the other goes up. What a thermistor does is the opposite of that. So as we increase the temperature, the resistance of the thermistor decreases. And so we end up, if I was to plot it on a graph, with a shape that looks like that. So that shows temperature is inversely proportional to resistance. Okay, so that's what the relationship is for a thermistor. So it's just the opposite of a regular resistor. If you increase the temperature, you decrease the resistance. In this case, what happens to increase the temperature is in your lattice, we have our positive metal cations surrounded by our delocalized electrons, which are moving about through that lattice, bumping into the ions. So we have electron-ion collisions. And as we increase the temperature, what happens is each of these positive metal ions increases their kinetic energy. So they're going to vibrate more and they're going to move around more. So because they're vibrating a lot more, these electrons are more likely to collide with them, and hence the resistance increases. To understand how a thermistor works is a little bit more complicated, but in a nutshell, a thermistor is a type of device called a semiconductor. And semiconductors are made from materials which typically shouldn't be conductors. So most fixed resistors are effectively just wires, so they might be made out of copper. But an example of a semiconducting material might be something like silicon. Now, silicon normally on its own doesn't conduct, but what we do with the silicon to make it become a semiconductor so that it does conduct, and not only that it conducts really well, is we add some impurities to it. So the difference would be, imagine that if I have my metal lattice now, I would maybe have silicon, silicon. So each of these would be silicon ions, and then what I would do with a semiconductor is I would have maybe one aluminium as an example. Or I could also have phosphorus. Now, on the periodic table, aluminium, silicon, and phosphorus all sit next to each other. So what happens is if I was to add an aluminium, I am basically, there is one less electron there than what there should be. If you imagine like this is all one specific type of material, each one gives the same number of outer shell electrons. Silicon has 4 electrons in its outer shell, whereas aluminium only has 3. So for that reason, that because it only has 3, there's effectively like a little gap here, and what that little gap means is that the electrons can jump into it. Or if I did this with phosphorus and I added a phosphorus impurity, I would add an extra electron, which again means there's an extra electron to flow around and hence conduct. So that it's a little bit trickier to understand how a semiconductor works, and it's not something you're going to be asked about in your exam. But just so that you understand how a thermistor works, a thermistor is this type of material. It is a semiconductor, and by changing the temperature, then what you do is you affect the energy required to move the electrons through the material, and so it's because how it affects this impurity that causes the drop in the resistance when you increase the temperature. So you don't need to understand that process and how a semiconductor works for your exam. You're not ever going to be asked to explain that, but you need to know the key idea, which is that a thermistor, as the temperature increases, resistance decreases, is inversely proportional. Okay, and that is just a little bit of extra context just so that you can understand a little bit of how that works. Now the final component we need to talk about is the LDR, which stands for the light dependent resistor. So you can see it's like a regular resistor but with two arrows showing light coming in from the top left. So as we this time, rather than have temperature on the bottom, we have light intensity. So it works in exactly the same way as a thermistor, as the light intensity increases, so as it gets brighter, the resistance decreases. So this time resistance is directly proportional to 1 over the light intensity. So light intensity is inversely proportional to resistance in this case. Okay. Now, put these two components, thermistors and LDRs, can be really important in a circuit, because if I have a really simple circuit with a power supply and a thermistor and say a bulb, for example, the power supply is going to provide an EMF and the potential difference is going to be across each of these components. So let's just say, for example, that the EMF of this is 6 volts. And so if these two components were identical, if they were, in terms of their resistance, then I'd get 3 volts and 3 volts. However, if I increase the temperature then, so that I increase the temperature on my thermistor, that is going to decrease the resistance. Now I need to then look at how resistance is related to both potential difference and current. So if I'm reducing the overall resistance of the whole circuit, I'm going to increase the current. And by increasing the current going through my by going through my circuit, if the resistance of this is constant and I increase the current, I'm going to increase the potential difference here. So in other words, by reducing the resistance here, the voltage is going to decrease. By increasing the current here, the voltage here, or the potential difference, is going to increase. So in other words, the bulb is going to get brighter. Okay. If this was a motor, it would spin faster. So it's important that you understand this idea that if the temperature increases, the resistance decreases. That is going to drop the drop the potential difference across that, and that energy has to go somewhere else. So it's going to go to the other component, which is going to increase. If you did the opposite of this, if I drop the temperature, the resistance would increase, the potential difference would go here, the bulb would get dimmer. Okay, so that's thermistors and LDRs and how they work. And you need to be able to not only describe how they work and then circuit symbols for them. You don't need to be able to explain this bit, but you do need to be able to explain how regular resistance works, and you need to be able to apply them to basic circuits and be able to make predictions about what would happen to this component here.